Okay, section 2.3, the precise definition limit. We are not going to do much with this at all, very little indeed. This is a topic that you wouldn't really be expected to understand until you were in some upper division math class. And for you engineering types, whether you would ever actually have to understand this, I'm not sure. I've never taken an engineering class. But I just, from a cultural standpoint, what mathematicians consider precise and definitions and stuff. So we have here the precise definition of a limit. Let f of x be defined on some open interval about x naught, x sub 0, mathematicians usually say x naught, except possibly at x naught itself. We say the limit of f of x as x approaches x naught is the number L, and we write the limit as x approaches x naught of f of x equals L if for every epsilon there exists a delta greater than 0, such that if 0 is less than the absolute value of x minus x naught is less than delta, then the absolute value of f of x minus L is less than epsilon. So this symbol here, that's lowercase Greek letter epsilon, and it represents a very, very, very small positive number. And the same thing, that symbol there, lowercase delta, and it too represents a very, very, very small positive number. We're talking small on the size of an electron, incredibly small as you can envision something being. That's how we're envisioning it. Okay, my slight attempt at trying to get you to understand what this says. I'm going to have a function here. And I've got some number on the x-axis, x naught, and I've got my limit value on the y-axis, L, and then I've got some sort of function that may or may not be defined at x naught. That's not important. So you've got this going on. Then, delta. Delta is a distance on either side of x naught. So this over here would be x naught minus delta, and that over there would be x naught plus delta. So all delta is a distance on either side of x naught. And what epsilon is the corresponding distance on either side of L. So that'd be L minus epsilon, and that'd be L plus epsilon. So that's what we've got going on graphically. Now, what this statement is saying is the limit exists that anytime you tell me I want to be within epsilon distance, I want to be within 1 atom's width of L, I will always be able to find a corresponding distance around x naught to make it happen. That if I tell you I want to be 1 electron's width, that no matter how small, and this picture is magnified billions and billions and billions of times, that no matter how close I say you need to get to L, no matter how close I say you need to get to L, you will always be able to find a corresponding distance around x naught to make it happen. That no matter how close I want to be there will always be a corresponding distance down there that will make it happen. Now, again, not important at this point in your life that you understand this. We aren't going to do any problems with it. All I'm going to ask you to do is the following. And note, on both a quiz and test, you will be asked to state the following. State the precise definition of limit as x goes to 0 of f of x equals L. You are to answer the following. The limit as x goes to x naught at f of x equals L means for every epsilon greater than 0, there exists a delta greater than 0, such that if x is less than the absolute value of x minus x naught is less than delta, then the absolute value of f of x minus L is less than epsilon. You need to memorize that because it's going to be on a test. That's all that we're going to do from this section. That I'm going to ask you on a test and quiz to state that. You write it perfectly, you get all the points. You write it imperfectly, you get none of the points. And that's what it says down there. There will be no partial credit awarded, I should say awarded, it says awarded for this problem. Either the definition is stated perfectly and full credit is awarded, or the definition is not perfect and no credit is awarded. You need to memorize that. And that's all. And then when you do your homework in section 2.3, there's one question where it says, you will be asked to state this definition, true or false. The answer is true. Memorize it. And that concludes the lecture from section 2.3. You can do the homework over that now.